Hey guys, welcome to the second video of my series on concurrent programming in Python. So in the first video, we tried to understand what concurrent programming actually is, and in this video, we're going to try to understand one of the most fundamental components of the concurrent programming, which is coroutines. So without any delay, let's get started. So in very simple words, a coroutine is a simple function which can pause and resume its execution. So it is basically a function with some superpowers that it is able to pause and resume its execution at any stage during its complete life cycle. Okay, so let us try to understand it with an example. Let us say you have three functions in your code: function A, B, or C, or rather let us call it coroutine. So you have coroutine A, coroutine B, and coroutine C. So now what you do is you start the coroutine A. So you have started the coroutine A, and after some stage you decide to pause the execution of your coroutine right here, and then you start the execution of B. Now B is executing. At some stage you stop B, and now C is executing. At some stage you stop C, and then again you start executing A. Then again you stop A, then B is executing, and then again from where C had left off, C will start executing it again. So in this way, coroutines work. So coroutines can pause and resume their execution, and one coroutine, when it pauses itself, it can call another coroutine and it will execute. So in this way, coroutines work. But now the question comes, how do I make coroutines in Python, right? So in order to make a coroutine, you actually need to have a function which you convert to a coroutine. So for example, all you have to do actually is that you have to just put an async keyword. Async is a Python keyword which you can use, and as soon as you put async before the definition of any function in Python, it becomes a coroutine. So let me give an example here. Let's say I do async. Or okay, let us first go with a very simple function. Let me call it a function called main, in which we do print hello. Okay, it's a very simple function, and now what I do is I simply do main. I simply call main. Look at that. What I get hello. Now the thing is that I am gonna make it a coroutine. A coroutine, a function with special powers which allow it to pause or resume its operation at any stage during its life cycle. So now let me just put async. So now what happens is, let us try to see what if I call main. Look at that. It actually returned me something. It returned me a coroutine object. So now the thing to understand here is that as soon as you put async before a function definition, it becomes a coroutine. And when you call that coroutine, it returns a coroutine object. Now a coroutine object can be executed using different means, which we are going to try to understand in the next video. But for now, the thing to understand here is that when you call a coroutine, you do not execute that function actually. You in return, you actually get a coroutine object which can be executed by some other means. So now one more thing that we try to understand before we stop this video right here is that we understood that how do we make a coroutine in Python, right? But how do I pause a coroutine in Python? So in order to pause a coroutine in Python, we have something called await keyword. So all you have to do is, in the definition of your coroutine, you have to just put an await keyword followed by some awaitable object, and what will happen is that as soon as this statement will be encountered, your execution of current coroutine, which means that this particular function will stop right there, and the awaitable object will start running. And as soon as awaitable object is complete, only after that your remaining part of your this particular coroutine will execute itself again. So, what are awaitable objects, right? So, what are awaitable objects? An awaitable object can be another routine, another coroutine, or a task or a future. So now task and future are actually defined in a built-in Python library called async IO. So async IO is a specialized Python built-in library which helps you do concurrent asynchronous programming in Python. And task is one of the fundamental objects defined in the async IO library. So what do we use a task for? We use a task for scheduling the coroutines. So you can schedule the coroutines. Let's say you have multiple coroutines, then you want to schedule them. Then how do you schedule them? In order to schedule them easily, what you can do is that you can wrap your coroutines into something we call as a task. you make their task objects. And how do you make that task object is done using a very simple function called async io.create task. So everything related to async IO we're going to see in the next video. But right now the thing to understand is that you can have a coroutine converted to a task, and then you can schedule it to run concurrently. So an await can take a coroutine or a task, and lastly a future. So what is a future? Future is another low level awaitable object which represents an eventual result of an asynchronous operation. So future is basically a base class, you can say, of some higher level classes which are used in the async IO library. So future can also be used here as an awaitable object. So in this way you can pause the execution of a coroutine. So now I will stop this video also right here, and if you still have any doubts you can put them in the comment section below. That's it from this video. Thanks for watching.